Hey everybody, my name is Mike Egner. I work for the West Virginia Division of Air Quality. I have a bachelor's degree in chemical engineering from West Virginia Tech. I have a master's degree in engineering from Marshall University Graduate College. I've also taught at Marshall University Graduate College in a variety of environmental classes, as well as chemistry at Bridge Valley. Today we are going to talk about air pollution control devices. One of the ways that we're going to start with is from coal-fired power plants. I'm going to show you a picture of a coal-fired power plant. This is John Amos. It's located across the river from Poca, West Virginia. Now what you see on the bottom, this black stuff, of course that's coal. When they burn coal, they produce two things, heat and pollution. The heat they use to heat up water in boilers to make steam. If you've ever seen a steam kettle, you see the pressure of that steam that comes out. Now, what do they do with the steam here? They send it through turbines. What's a turbine? This has fan blades that goes all the way through it. So you see where the steam goes in, it spins the fan blades, and that's what makes our electricity that we use. Now, after I said that they made heat and pollution, so now they need to treat the pollution. The pollution is treated through taking out a particulate matter in one section of the facility, and then they have what's called a scrubber, which is like a shower that has droplets that will catch on, and then that will fall to the bottom. After that's done, it goes up these stacks. This is the clean air that comes up the stacks. What you see coming out is not smoke, it's water vapor or steam. If there was any type of pollution coming out, this would be a different color if it was particulate matter. Or you see how this water vapor dissipates? So if there was pollution, it would just keep streaming down through there. Now what do they do with the steam? You see these hourglass? These are called cooling towers. So they take water from a pond or a river, put them down to cool the steam back into water so it can be reused again, and then they send that to the river. Now we're going to show you a couple ways that you can take particulate matter out of a coal-fired power plant. All right, so what we have here is an example of an industrial coal-fired boiler. We're going to show you one of the ways an air pollution control device can take smoke out of the air. So I'm going to take this off. And I am going to take dry ice. What's dry ice? Dry ice is solid carbon dioxide. I'm using a glove because this is at negative 109 degrees Fahrenheit. If I didn't use this glove, I would get frostbite. So dry ice is a little funny in that it sublimes. Sublime is just a funny word that means it goes directly from a solid to a gas. It's not liquid, it's not going to melt. So a pretend smoke is I'm going to pour hot water into this and it's going to generate water vapor, but we're going to pretend that it's smoke. So I'm adding hot water to my dry ice. Oh, look at that. So here's our pretend smoke. Put the lid on it, I'm going to plug it in, and we're going to see what happens when I take air out. Now you see the green streamer. Do you see any smoke coming out? Nothing, right? Let me switch. Now we're going to use the red streamer. Oh my goodness, look at that. I can't even see it. So now, I'm going to do both at the same time. I've got them both coming at the same time. No smoke coming out of this. Lots of smoke coming out of here. What's the only difference between these two? Now I know they're different streamer colors, but that's not the reason. If you look at the bottom, the one on your right, do you see the little paper towel? So that's our paper filter. You don't see one on the other side. So what happens is you have a bag house which is simply like a vacuum cleaner bag where you have the dirty air that goes through, the clean air comes out the side, and the particulate matter gets stuck. They use what's called mechanical wrappers, tap, tap, tap. The particulate matter falls down to the bottom, and they send that to the landfill. So this is one of the ways that we can take particulate matter out of an airstream. All right, so this is a different type of air pollution control device for particulate matter. This is called an electrostatic precipitator, or ESP. So what happens is I'm going to spin these wheels, and it's going to be like when you scoop your feet and you touch somebody and it shocks them. That generates static electricity. Now, this is not exactly what they use for ESPs in the power plants, but we're going to show you a Wimshurst machine and how it works to make static electricity. Alright, so what I'm going to do is I'm going to take these two discs that have different metals on them, we're going to spin them around, and we're going to generate static electricity. Static electricity is just like in the winter when you scoot your feet on the carpet and you touch somebody and you get that spark. That's electricity, static electricity. What's going to happen in this case is the electricity is going to go through these corona wires into these tubes, which we call capacitors. Capacitors store up the charge until you get to a certain amount and it releases it. How much in this case? 60,000 volts of electricity. Once it gets to 60,000 volts, the electricity goes through the positive pole here, the negative pole here, and they're going to come together and we're going to see a spark. $60,000 volts. So you can see how quickly the capacitors are building up and how fast they're releasing that amount of electricity. Now, I'm going to take that electricity that I've been making and I'm going to run it through the barbed wire and this plate. The positive end is going to be the barbed wire, the negative end is going to be the plate. Now with an ESP, what happens is the smoke that comes up is made of teeny tiny dust particles. The positive charge from the barbed wire is going to be attached to the plate, the ions of the smoke, which in turn will be drawn to the negative end of the plate. Opposites attract. Alright, so now to demonstrate this, I'm going to use a smoke pen. Where do you get a smoke pen? The same place you get everything else, Amazon. So I'm taking my smoke pen and I'm going to put it down here and simulate the smoke that's coming out. Now uncontrolled, look at all that smoke. You would not want to be living down there. But now I'm going to generate a charge. Look what happens to the smoke. You see it coming out the top? No. Where is it going? Well, if you look at here at the bottom, you can see it being collected on the plate. What happens if I stop? Uncontrolled. Look at all that dust coming out. Now imagine it from a power plant. Controlled, it's going to go and stick to the plate. Now what happens with the dust on the plate is the same thing that happens otherwise. You have wrappers, tap, 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 the dust falls to the bottom, it gets taken to the landfill. Alright, my smoke pen is lit. I'm going to blow it out. I'm going to put it in the cylinder, and you see the smoke going up on top. We've got a clean plate. I want to see how much smoke that we can attract onto the plate. Again, the electricity is running. We're charging the dust particles. If I stop, you see the dust going out the top. So I'm running the electricity again. It's attracting the smoke particles. And I want to see how much we can actually get on that plate. The amount that we get on the plate shows how much is not going into the atmosphere. So I'm going to let it run for just a bit. Alright.
capping the pen. I'm going to take the cylinder off and set it aside. And let's see what happened. I can draw a smiley face. Now, let's see how much dust I can wipe off here. Look at all that dust.
Alright, so this is Mike again. We've talked about two different types of particulate matter control devices. Now we're going to talk about more science. Science! So one of the things that happens when you burn coal is the sulfur. We talked about the sulfur content. Well, when the sulfur gets in the air, what happens is the sulfur dioxide and sulfur trioxide forms with water to form acid rain. Acid rain is an issue if it gets into the sky. Now, if you've seen the Statue of Liberty, you've seen the streaks that fall down, that's from acid rain. You've seen statues that are deteriorating, that's caused by acid rain. So that's one of the reasons that they put in those scrubbers, is to take the sulfur from getting into the atmosphere. Another issue with acidic water is acid mine drainage. When you have a coal mine that's open, rainwater will get into it or different water will get into it, it turns acidic. And what happens is when it turns acidic, that means the pH drops. We're going to talk about pH in a second. When it gets acidic, it leaches that iron that's in, and then it goes out into the stream. When it's in the stream, the pH turns back to normal. Now, have you ever seen a stream that looks orange like this? Now, would you want to drink that water? No. Would you want to swim in that water? No. Dr. Fauci recommends against it. So what happens is when iron gets back into the water, it turns to neutral pH. You see the iron, that's why it's orange, iron. Now, one of the ways that we treat the water's state is we add something that will be the opposite of an acid, which is a base, or limestone in this case. Now, here's a picture of a helicopter bringing in limestone. Do you see the bucket on the bottom? It doesn't look very big, does it? Well, that's from this angle. Let me show you another picture. Here is the same bucket. Look how big it is now. See all the limestone in the back? So they add the limestone to the acidic water. The acids and the bases cancel out. And that's how that we treat acid mine drainage. Now I'm going to show you a close-up what pH is and how it affects different acids and bases.
So we were talking about acid rain and acid mine drainage and some of the problems that we talked about in pH. Well, here's a pH chart. pH was actually discovered by a Danish chemist called Søren Sørensen, who came up with the idea in 1909. Now, we're not quite sure today whether he meant to call it the potential difference of hydrogen or the negative power of hydrogen ions. When he wrote the papers in French, Danish, and German, they all had the letter P, so it could be either power or potential. So it's either the power or potential of hydrogen. Now, where we have is a logarithmic chart. All that is a fancy name that means steps of 10. So if we start in the middle at 7, we call that a neutral pH. As we go farther and farther down the scale, we get more and more acidic. But each step will get you a factor of 10. So if we go from a pH of 7 to a pH of 6, then we've gone 10 times more acidic. If we go from 7 to 5, that's 2 steps. 10 times 10 is 100. 100 times more acidic. If we go 3 steps, that's 10 times 10 is 100. 100 times 10 is 1,000. 1,000 times more acidic just by each one of these steps. Now, one of the ways that we can measure pH is what's called pH paper. So I'm going to take the paper and match it up so that it corresponds with what we have here. The first thing that we're going to try is drinking water. Now, this drinking water is past its expiration date. I'm not sure what happened to the ions in the water to cause that to happen, but there you are. So I'm going to take the pH paper and I'm going to match up what color it is. Is it here? Is it here? Is it here? It looks like it's dead on. A pH of 7. So drinking water has a normal pH of 7. Your blood is very, very close to a pH of 7. Alright, so we're going to change the pH by changing the acidity. For the acidity, we're going to add lemon juice. And we're going to make some lemonade. So now I'm going to mix that up a little bit. I'm going to add a paper to it. Let's see what happens. Alright, so I added the lemon juice. I said it was going to be acidic. We're looking at 7. Nope. 6. Nope. 5. Oh, no. 4. No. 3. 2. Somewhere. Let's call it 3. So we went from 7 to 6 to 5 to 4 to 3. So we went 4 steps. 10 times 10 is 100. 100 times 10 is 1,000. 1,000 times 10 is 10,000. So 10, 100, 1,000, 10,000 times more acidic by adding lemon juice. Now we can go in the opposite direction. As you go from neutral in this direction, it becomes more alkaline or more basic. So if we go from 7 to 8, that would make it more basic or more alkaline 10 times. If we went from 7 to 9, it would be 100 times more alkaline. So what I'm going to do to neutralize the acid is to add a base. The base that I'm using today is baking soda. Now, do you think I need to add a little bit of baking soda or a lot of baking soda? Let's find out. I didn't bring my spoon with me today, so I'm just going to pour just a little bit. Just a little. Uh-oh. Oh, no! Volcano! 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 I think I've made a mess. Alright. So now, if I can get any liquid out of this, I am going to test the pH. Let me take this out. Take it in here. Put this back. Let's see where we ended up. 3, no. 4, no. 5, no. 6, no. 7, no. 8, 9. I think it's 8. So now we've gone from 3 to 4 to 5 to 6 to 7 to 8. How many steps is that? 1, 2, 3, 4, 5 steps. 10 times 10 is 100. 100 times 10 is 1,000. 1,000 times 10 is 10,000. And 10,000 times 10 is 100,000. So it's 100,000 times more basic. Let me clean up my mess. My volcano runneth over. Alright, so other objects or substances or liquids have different pHs. Let's try something new. How about, what do I have here? How about pickle juice? What do you think the pH of pickle juice is going to be? I have a cousin who loves to drink pickle juice. Now myself, I like to eat pickles, but I'm not a big fan of pickle juice. So, it's going to be acidic. Is it going to be basic? Is it going to be neutral? Let's find out. Alright, let's see what we got here. Let this dry. 7, 6, 5. What do you think? 5, 6? We'll call it 5. So pickle juice is 100 times more acidic than neutral. What else do I have to work with? I've got Diet Pepsi. Now Diet Pepsi is soda, and especially with Coke and Pepsi that has sugar in it, your dentist warns you that you shouldn't be drinking it because it's acidic and it harms your teeth. What happens is it eats the enamel off your teeth. So if you do drink your Coke, please brush your teeth afterwards. Let's see where Diet Pepsi gets us. 7, 6, 5, 4, 5, 6. So somewhere between 5 and 6. Again, Diet Pepsi doesn't have the sugar in it that your Coke does, which has a pH of around 3. What else do I have? I've got hand sanitizer. I wonder if that's acidic. It's got at least 70% alcohol, or it wouldn't be hand sanitizer. So, let's see what we get. Alright, is it 7? 6, 7, 8? Oh! Are we moving down the scale? So that is hand sanitizer. What else do I have? I have vinegar. What do you think the pH of vinegar is going to be? I'll give you a hint. If you can read the label, it says 5% acidity. Let's see what 5% acidity will get us. 7? Nope. 6? Nope. 5? Nope. 4? 3? 2? 3? 2? Let's call it 2. If we call it 2, then we went from neutral, and we went 1, 2, 3, 4, 5 steps. 10, 100, 1,000, 10,000, 100,000 times. What else do I have here? Let's go in the opposite direction. This is oven cleaner. Oven cleaner is very, very dangerous to use. And it's dangerous because it does its job so well. Now, instead of being very acidic, it's very alkaline. So I'm going to give it one little spritz. Just one little spritz. Up! Do not try this at home. Dr. Fauci does not recommend it. So look what I got here. Ooh, 12, 13, 14. Oven cleaner has a pH of 13. So now we've gone in the alkaline or basic direction. How many steps? 1, 2, 3, 4, 5, 6. So that would be 10, 100, 1,000, 10,000, 100,000, 1 million. 1 million times more alkaline than neutral water. That's the reason they make it, is because it works, and that's why we leave it underneath the counter. Let's see what else I have to work with. How about canola oil? Why did I pick canola oil? I was going through my cabinets, and that's what came out. We're going to try canola oil. Alright. Let's see where it got us. 7? Yeah? 6? Maybe? 7? So canola oil is pretty neutral. Let me wipe up my mess here. Alright, what's next? What's next on my list? How about Clorox? I'm not going to use a regular glass because this is straight bleach. So I am going to pour a little bit, and we're going to see what the pH of bleach is. So I'm going to take a sample, and we're going to see that it is around 11, 12, 13. So again, very, very, very alkaline. Now, if you're trying to make sanitizer at home, they tell you to use either about a half a cup of bleach per gallon of water. Now, since I don't want to make that much, I got a, it says professional sprayer. It just tells you how many ounces that you have here. So what you do is you add 2.5 ounces of bleach that I just had, and you fill it up to the 20 ounce mark. So 2.5 teaspoons, not tablespoons, teaspoons will get you 20 ounces of sanitizer that you can use at home to clean it. I wonder what the pH of this watered down bleach is going to be. Ooh, look at that. 7? Nope. 8? Maybe. 9? Possibly. So somewhere between 8 and 9. You remember where we were at 13, 12, and 13 before when it was solid? Now we dropped down to between 8 and 9. So that is all of the things I found to show you of pH. I appreciate the time to watch this video. I hope you enjoyed it. Go DEP. And just for fun, because I don't like to waste dry ice, I've got 4 pots of boiling water. Let's see what happens. Back in the olden days, they used to make this as fog for musicians for their rock concerts, and they also use them for movies. Holy moly, look at that. Again, it's sublimation. It's going directly from a solid to a gas. It's just the water that was boiling is what heats it up. How cool is that? Negative 109 degrees Fahrenheit, instantly becoming a vapor.